Remember that the goal for today's lesson is for you to be able to graph a proportional relationship. Even if you only have 1 point, you should be able to do that. And then also for you to be able to find the constant of proportionality using a graph. And so to start with, let's say we're faced with a problem like this, where we've got a graph and then a table down here and some questions they're going to ask about us. So the first thing I might start doing before I even read these questions is just take a moment to look at this graph to figure out, what do I know about the situation? And so we have here that Tyler's at an amusement park. He walks at a steady pace from the ticket booth to the bumper cars. And so this term right here, steady pace, is going to give me a clue that this is going to be a proportional relationship. And so if I see here, it looks like I've got elapsed time in seconds is my independent, my x, and my distance from the ticket booth in meters is my dependent variable, or my y. So I'm going to label both those just so I can kind of have that in the back of my brain. And so we know that these proportional relationships will start here at 0, 0 at our origin. So I can put a point right there. And I know that proportional relationships, remember, they will always follow in a straight line. And so I know that this graph has to run from 0, 0 up to this point here at 40, 50. And so when I think about this here, where this question where it says the point on the graph shows his arrival at the bumper cars, what do the coordinates of the point tell us about the situation? And so this point here is reflecting, well, after 40 seconds in time, he was here at 50 meters. And so that tells us that the bumper cars are 50 meters from the ticket booth. Here at 0, 0, we would say, well, he hasn't started any distance or any time. And so this would be like where we started, his starting location and his starting time. And so, that's this point right here, this 0, 0 right there. And I think I accidentally just answered this question. And so this is why I like to start to look at this graph before I even try to answer the questions, because unintentionally I just answered a couple questions just by trying to make sense of what I see up here. So that, again, this point here at 0, 0 mean in this particular situation, it means that when 0 time had elapsed, he had covered 0 distance. And so Tyler is right here where we can say, like, this is actually the ticket booth. We could label that right there. And we could also label this point here, 40, 50, as our, what is this? The bumper cars. And so sometimes it's helpful when you're trying to connect this math to the real world is to actually label what's the real world example of what this is. Again, because it told us as a steady pace, I know it's going to be a proportional relationship, and so it's going to continue at a straight line. And so if I look at these points down here, we've got some tables representing his walk, and I've got a spot down here where I need to try and figure out what number goes there. And so remember, there's 2 ways we can figure out that constant of proportionality using this table. One way is if I look at this, if I notice in my time, I'm kind of increasing by 10. So every time I go down, I'm adding 10, I'm adding 10. And if I look over here, I'm adding 12.5, I'm adding 12.5. And so I could write that as a ratio, right? My change in my y over my change in my x, right? And that would get me down to a simplified ratio there of 1.25. Alternatively, I can also look at another way to find that constant of proportionality is to think, what do I need to multiply this x value by so it looks like that y value? So I could write that math equation as 20 times x equals 25. Again, I'm thinking about this x here is our constant of proportionality. Remember, our standard equation is that y equals kx, where this k is that constant of proportionality. And so we're trying to figure out, what do I need to multiply x by so that it looks like 25? I can use my inverse operations, and since this is multiplication, I can divide both sides by 20, and I get x equals, well, now I've got 25 divided by 20. We can simplify that down into 5 over 4. Again, somehow in elementary school, we drill into your brain that improper fractions are bad. They're not. They're fine. Leave it just like that. That's a beautiful way to leave that number. If that makes your brain freak out a little bit, just convert it into a decimal, and we see, yep, those are the same numbers. And so I could check my work down here to make sure that this is in fact my constant of proportionality by plugging it in. I can take 30 times 1.25, and if this is true on my constant of proportionality, I'll use my calculator here just to confirm it. I can take 30 times 1.25. Oh yeah, 37.5, that's what I wanted. Beautiful. So I'm fine if you use a calculator to check your work like that. I just want to be able to see the math that you did. And so now that helps me answer this question down here. Well, what do I need to multiply 1 by so it looks like 1.25? Or another way to think about that is I can multiply 1 times 1.25, my constant of proportionality, and that's going to be the number I would put in right there. And so what that tells us here, this constant of proportionality, what does this tell us about this particular relationship between time and distance? What that's really getting at is that Tyler is walking at a speed of 1.25 meters per second. So he's going to progress 1.2 meters in this direction as he goes forward in time 1 second. And so if I were to plot these points on this grid, well, I know that it has to run through the straight line. So I might even start by connecting with a straight edge, 40 and my origin 0, 0 down here. And please use a straight edge. Don't try to eyeball this. Like, you should use a straight edge. Mine's a little bit off because of my, whatever this thing is, the stand of my iPad. But you should use a straight edge, just because I think that's an important tool for precision. And now I can double check to make sure this is my X and this is my Y coordinates. Let's go ahead and plot these to confirm. And this is telling us that at 20 seconds, Tyler is at 25 meters, and that's exactly on the line where we thought it should be. We've got 30 seconds and 37.5. Again, right on the line, exactly where we thought it should be. And then 40, 50 is already plotted for us. And we can confirm, 1 and 1.25. That's hard to see on this little tiny graph, right? But we think, well, here's 5, so 1's going to be about right here. And yeah, that makes sense. It's not exactly 1 to 1, right? Because it's 1 and 1.25. So this is a valuable way that you can use a graph to help you understand more about proportional relationships. Again, key takeaways from this is that your proportional relationship will always fall on that straight line. And we're going to start it at 0, 0. And so as long as you have one other point, you can connect those 2 points. I can also use this graph to help me find my constant of proportionality by doing the same strategy I did down here, where in the table I was looking for, well, how much did I change in my X and how much did I change in my Y? I can use this graph right here and I can think, okay, well, to go from 20 to 30, I need to go, draw it this way, that's plus 10. And to go from 25 to 37.5, I'm going to go up 12.5. And I could write that as, again, that ratio of 12.5 over 10. And again, we think about this as the change in Y over the change in X. And this little triangle right here just means change. So it's a good way we can use a graph to help us find the constant of proportionality. We'll learn in our later modules, this is actually called the slope. We're going to come back to this idea a whole bunch in the subsequent modules. Okay, there's a few more final notes I'd like you to copy down into your math notebook, and then you can head over to the practice problems.